we will find the Laplace transform for this function. On the test, you should be able to see the table of the Laplace transform. So you see that on the right hand side here. So it's very easy. Or we just look for the corresponding formulas, like 3t squared e to negative t. And then we just look at something like this. And then actually that for the second function. That should be simple. Right. But first, what we see here is that because the way we define the Laplace transform in terms of integration, which is a linear operator, so we can just write this as 3 times Laplace transform of t squared e to the negative 9t minus the Laplace transform of e to the 5t cosine square root of 7t. So that is the linear properties of Laplace transform. And then we just use the formula. I just want to do that a little bit different than just the formula. What we see here is that every time we have e to the something t, something like this, that's going to be a transform of the function. So in that case, we will only do the Laplace transform for t squared. But whatever the result we have, we go from s to s plus 9. So that is the old school way to do the Laplace transform. And then we just do the Laplace transform. Once again, here we have e to the 5t. So all we need to do is just transform the cosine of square root of 7t. And then whatever result we have, we go from s to s minus 5. Of course, if we use this formula and this formula, we can get exactly the solution we have. Right. So we have 3. The transform of t squared, I'm going to use that formula will be, so it's going to be 2 factorial s n plus 1, s to the n plus 1. But notice that since we go from s to s plus 9, so instead of s, it's going to be s plus 9. Cube. And then next, we have Laplace transform of cosine. I'm going to use this one. Will be s over s squared plus b squared. B is square root of 7 squared. But notice that instead of s, it's going to be s minus 5. And then s minus 5 here. Instead of s. So that is the Laplace transform. I just rewrite that. The top is 2, so 6 s plus 9 cubed. And then minus s minus 5 over s minus 5 squared plus 7. Right. And then just a little things. For the transformation of this function, if we look at that, we require that s is greater than a. A in this case is negative 9. So we have s is greater than negative 9 for that function. And for this function, we will take a look at this. And we also have s greater than a, which is 5. So we have s greater than -9 and s greater than 5. Put them together. S have to be greater than 5. Because if s is greater than 5, it certainly will be greater than -9. So we have to choose the bigger value to accommodate both of them. Right. Next we have another Laplace transform, -2t cubed plus 1 and then 2 sine of 3t. Again, we don't have to use the Laplace transform using a transformation like this. We can just look directly to the formula and use it. But I just want to do it a little bit differently. Right. Again, the first thing we do for the Laplace transform is the linear property. We can write the Laplace transform of little function like this. And then we just have the formula. T cubed is going to be 3 factorial over s to the 4th. And then plus transform of 1 is 1 over s. And transform of that is going to be 2 times transform of the sine function is going to be b, which is 3 in this case, and then s squared plus b squared. B is again is 3 in this case, so that s squared plus 9. So we should have 3 factorial is 6, so that's -12 over s to the 4th power plus 1 over s plus 6 over s squared plus 3. And we have all of that s greater than 0 to make sense. So that would be defined. So s is greater than 0. And that's what we have.